Hi, we have the AP Physics 1 past paper 2018. We are discussing the section free response question. In question 1, carry the point 7. The spacecraft of the mass m is clockwise circular orbit of the radius r around the Earth. As shown in a figure above, the mass of Earth is me. Okay, in the fig is not according to the scale. A spacecraft is revolving around the Earth. There is a distance from the center of Earth to the spacecraft, that is r. Now, in part A question, draw the label of forces, not the component that act on spacecraft. Each force must be represented by the distinct arrow starting on and pointing away from the spacecraft. Okay. As we know that when spacecraft is moving around the Earth, the only force acting is gravity from the Earth. So gravitational force point toward the center of the Earth. Here we can represent the arrowhead toward the center of Earth, and that there is only one force represented in a red vector that is pointed towards center. This is question for the 2 point. In next part of derive the equation for orbital period of the spacecraft in terms of mass of satellite, mass of Earth, and the distance from the center of Earth with physical constant as appropriate. If you need to draw anything other than you want, you have to show in part A to assist your solution. Use the space below. Don't add anything to the figure in part A. Okay. The only force acting on a spacecraft is gravitational force. This comes from the part A, as we know that this gravitational force acts as a centripetal force to keep the spacecraft moving in a circle. So I have placed Fc is equal to mg. Fc stands for centripetal force, mv square by r. Gravitational force g me m over r, small m representing the mass of the satellite. It would be cancelled out. So v square is equal to gme over r. So only v is equal to square root gme over r. Now this is the velocity, orbital velocity of the satellite. Now s is equal to vt, t is equal to come s by v. That question is about the period. So period is the time take for the spacecraft to complete one revolution. So s is equal to 2 pi r over v. So we can place here value of v come to from here, so we can place v here. So square root gm e over r. Now r can be moved up. 2 pi r can be accumulate into square root 2 pi square root r cube over gme. This is the time period of the spacecraft for one revolution. Okay. In next part, the second spacecraft of the mass 2m is placed in circular orbit with the same radius r. The new orbital period of the second spacecraft greater than, less than, or equal to the period of the first spacecraft. Explain the briefing. As in a previous relation, we have calculated the time period 2 pi square root r cube gme. Now it is questioning about the orbital period of the first. Compare. Second one has the same or greater than. From in calculation in the tool of the time period, there is no spacecraft mass. There is no m in a formula. So either mass is m, 2m, 3m. It doesn't affect the orbital time period. So t time period only depend upon the radius of the orbit and the mass of the planet. So we can say period of the second spacecraft is equal to the period of first spacecraft, as we discussed here. Now C part. The first spacecraft is moved into the new circular orbit that has the radius greater than r. As we can see, the new orbit is moving away from the figure below. Is the speed of spacecraft in new orbit greater than, less than, or equal than the original speed? Now we have come to know new radius is greater than the previous one. Old velocity we have calculated in the part B. Square root gme by r, new is stand for r prime. So when r prime is greater, speed will be less. G is constant, me is constant, so it is inversely related. Theoretically, larger orbit spacecraft further from the Earth, so gravitational force is weaker. Spacecraft require less centripetal force, so there is the orbital speed automatically becomes smaller. That's the theoretical explanation why the speed is going to less. Okay, that's the answer. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share with your friends. Okay, take care.